Now write down the conditional for Q and R. What is the conditional statement? If true and false, if T and F is F, in other cases it is true. The truth values in 4th and 6th column are same, hence they are logically equivalent. The conditional for X and Y, we have to verify whether this compound proposition is tautology, contradiction, or neither tautology nor contradiction. Just construct the truth table, that's it. Hello dear students, welcome to this session of model question paper discussion of mathematical foundation. I am Mr. Niranjan, faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. So in my previous class, we have discussed regarding 2 mark questions. So in this session, I am going to discuss regarding 8 mark one question. So one full question for 8 marks. In second part, you are going to answer for essay type questions. So each question carries 8 marks or some questions carries 6 marks. Now let us discuss regarding 8 marks. So you are going to answer 2 questions in this sub question, that is 13A, B or C and D. Now let us take the first problem, 13A. This carries 8 marks. Establish the truth table for the argument P conditional to Q conditional to R conjunction P disjunction negation Q conjunction R. This is the given compound statement. P conditional to Q conditional to R conjunction P disjunction negation Q conjunction R. So here there are 3 values P, Q, R. Now write down the truth table for P, Q, R. So for P, Q and R we are going to get 2 into 2 into 2, that is 2 to the 4, 4 to the 8 set of values. Now let us write the truth table for this. Now let us write first P, Q, R, P, Q, R. Write on P, Q, R. Then what we have? Q conditional to R, Q conditional to R. Then P conditional to Q conditional to R, P conditional to Q conditional to R. Right. Then so this is, let us represent this as X, the first part. This is X. And the second part, P already is there. Take negation of Q. Negation of Q. Then next, P disjunction negation Q. P disjunction negation Q. P disjunction negation Q. Then P disjunction negation Q conjunction R. Now let us call this as Y. Now what to write? Conjunction for X and Y. X conjunction Y. This is the truth table. Now just, so there are 8 set of values 1, 2, 3, 4, 5, 6, 7 and 8. One, 2, 3, 4, 5, 6, 7, 8. Now the truth values. For P it is true, 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 false, 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 false. So for Q, 2, 2, true, true, false, false, true, true, false, false. For R it is alternative, true, false, true, false, true, false, true, false. So this is very important. For Q, first 4 T, 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 remaining 4 are false, F, 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 F. For Q, 2, 2, first 2 are true, remaining 2 are true, false. For Q, first 2 are true, second false, again true, true, false, false, true, true, false, false, true, true, false, false. Whereas for R, alternative true, false, true, false. True, false, true, false, true, false, true, false. Now write down the conditional for Q and R. What is the conditional statement? If true and false, if T and F is F, in other cases it is true. So in case of conditional, T and T is T, T and F is F, F and T is T, F and F is also T, T and T is T, again T and F, truth and false is false, F and T is T, F and F is also T. So, in case of conditional, T and F is F, and in remaining cases it is true. Now, write down the conditional again for P and Q conditional to R. So, for these two, write down the conditional statement. So, conditional P conditional to Q conditional to R. So, again true and true is true, again true and false is false, true and true is true, true and true is also true, false and true is also true, false and false is also true, false and true is also true, false and true is also true. So, this is X. X is the conditional for P conditional to Q conditional to R. Now, write down the negation of Q. What is negation of Q? Negation of Q. True, true. True can be written as false, false. FF. This is TT. Again, FF and TT. The negation for Q. Now, write down the disjunction for P and negation Q. For P and negation Q, we are going to write the disjunction. So, in case of disjunction, false and false is false. In all cases, it is true. Right. So, here, so for these two, T and negation of Q, true and false is true. Again, true and false is also true. True and true is also true. True and true is also true. Again, false and false is false. False and false is false. Again, false and true is true. False and true is true. Right. So, in case of disjunction, false and false is false. In all cases, it is true. Now, let us write down the conjunction for these two. Conjunction for this and or. The conjunction for these two. Right. The conjunction. P disjunction, negation, Q conjunction or. So, in conjunction, true and true is true. In all cases, it is false. So, conjunction for these two. That is true and true is true. Again, true and false is false. Again, true and true is true. Again, true and false is false. Again, false and true is also false. Again, false and false is also false. Again, true and true is true. Again, true and false is equal to false. So, this is Y. Now, what to write the final step? Final one is conjunction between X and Y. Conjunction means true and true is true. In all cases, it is false. So, conjunction of true and true is true. Again, false and false is false. Again, true and true is true. True and false is false. Again, true and false is false. Again, true and false is also false. True and true is true. True and false is equal to false. So, this is the truth table for the given compound proposition P conditional to Q conditional to R, conjunction P disjunction, negation Q conjunction R. So, this is here you can observe, here this is neither tautology nor a contradiction, right. That is it. Hope you followed. Okay, this is for 8 marks. Move on to the next problem. Prove that, this is very simple problem, 13b. Prove that negation of P biconditional to Q is logically equivalent to negation Q. Okay. Now, just what is here P, Q, that is it given. Now, write down the truth table P, Q, then write down P biconditional to Q, P biconditional to Q, then negation of P biconditional to Q, then negation of Q, negation of Q. Now, so here P contains two true. Now, write down the truth values for this. For P it is true, false, false. For Q, true, false, false. P true, false, false. Q true, false, false. Alternative true, false, false. Now, biconditional, for biconditional, true and true is true, false and false is also true. For biconditional, true and true is true, false and false is also true, true and false is false, false and true is also false. Now, the negation of true is false, false is true, false is true, true is false. So, the negation of P biconditional to Q is F, T, T, F. Now, write down the negation for Q. What is the negation for Q? For true it is false, for false it is true, for true it is false, for false it is true. So, let us represent this as 1, 2, 3, 4 and 5. Now, check the truth values in 4th and 5th column. So, the truth values of 4th and 5th, false and false, true and true, true and true, false, false, true. So, you followed this. Now, move on to the next problem. Next problem is also for 8 marks. Prove that negation of P biconditional to Q is logically equivalent to P biconditional to negation Q. Very simple problem. Now, just write down the truth table for P biconditional to Q and negation of that. Again, P biconditional to negation of Q. Verify the truth values in these two are found to be same. If they are same, then they are logically equivalent. Now, write down first P, then Q, P biconditional to Q, P biconditional to Q, then the negation of P biconditional to Q, then negation of Q, and the last one is P biconditional to negation of Q. So, just split like this, okay. So, P biconditional to Q, negation of P biconditional to Q, negation Q, P biconditional to negation Q. Now, just write down the truth values. So, what are the truth values for this? For P, T, T, F, F. Here it is T, F, T, F, alternate. So, for P, T, T, F, F. For Q, alternatively true, false, true, false. Now, biconditional is true and true is true, false and false is also true. In other cases, it is false. So, true and true is true, true and false is false, false and true is false, false and false is also true. Now, write down the negation for this. Negation of T is F, F is T, F is T, T is F. So, negation of true is false, false is true, true is false. Now, the negation of Q, true is false, false is true, again true is false, false is true. This is the negation. Write down the biconditional for P and the negation of Q. So, the biconditional, again biconditional, true and false is false, again true and true is true, false and false is also true, false and true is equal to false. Now, just write down this as first column, second column, third column, fourth column, fifth column and sixth column. Just observe the truth values in fourth column. In fourth column we have F, T, T, F. In the sixth column also we have F, T, T, F, 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 T, 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 F, F. That means the truth values in fourth and sixth column are same, hence they are logically equivalent. So, therefore, we can conclude that negation of P biconditional to Q is logically equivalent to P biconditional to negation of Q. So, if you do this much, you will get definitely 8 marks. Very simple compared to the first problem. Now, let us move on to the next problem. What is the next problem? Question number R. This is the choice A, B, R, C and D. 13, C and D. This is the choice question for R. Now, if x is equal to 5, find the truth values for the following statements. Very simple. Negation of 2 less than x by conjunction x less than 3. Again, 2 greater than x conditional to x less than 5. Next, negation of 2 greater than x minus 1 by conditional to 3 greater than x. X square is greater than 5. Conjunction x minus 2 is greater than 5. Now, let us take one by one. First one, what is the first one we have? First one, negation of 2 less than x, and conjunction x is less than 3. When, what is the condition? If x is equal to 5. When x is equal to 5. Negation of 2 less than 5, conjunction 5 less than 3. So what is this equal to? This equal to, so negation of 2 is less than 5. 2 is less than 5. Yes, it is true. 2 is less than 5 is true. Conjunction. 5 is less than 3 is false, because 5 is greater than 3. See here. So 2 is less than 5, it is true. Conjunction. 5 is less than 3 is false, because 5 is greater than 3. So negation of T is F, conjunction F. So what is the conjunction for F and F? So the conjunction true and true is true. In all cases it is false. So false and false is equal to false. So therefore the first statement is false. So that is negation of 2 is less than x, conjunction x less than 3 is false. Now move on to the second one. What is the second one? Second one is 2 is greater than x, 2 greater than x, conditional to x less than 5. Same values, that is 2 is greater than, what is x? X is 5, conditional to 5 is less than 5. So this implies 2 is greater than 5. So 2 is not greater than 5, it is less than 5. So this is false. F conditional to 5 is less than 5. No, 5 is equal to 5. This is also false. So what do you say from this? In case of conditional, true and false is false. In all cases it is true. F and F is also true. So this is true. So therefore the statement 2 is greater than x, conditional to x is less than 5 is true. See here, when x is equal to 5, 2 is greater than 5. 2 is greater than 5 is a false statement, because 2 is less than 5. Conditional to x, 5 is less than 5 is again false, because x 5 is equal to 5, 5 is not less than 5. So both the statements are false. So in case of conditional, F and F is again true. Hope you follow. Now move on to the next one, third one. What is the third? So each carries 2 marks, 2 marks, 2 marks, 2 marks, 2 marks, totally 8 marks for all these 4. Now third one, negation of 2 greater than x minus 1, which is biconditional to 3 greater than x. So same, negation of 2 greater than x is 5 minus 1, biconditional to 3 greater than x is 5. Now simplify this. So this is nothing but negation of 2 greater than 5 minus 1 is 4, biconditional to 3 is greater than 5. So negation of, this is 2. 2 is not greater than 4. So it is false. 2 is less than 4. F biconditional to 3 is greater than 5. Again this is also false, right? So that is 2 is greater than 4 is false. 2 is not greater than 4. 2 is less than 4. So it is false. Again 3 is greater than 5. 3 is greater than 5 is again false, because 3 is less than 5. So negation of F is T, biconditional to F. So what is this equal to? Since in case of biconditional, true and true is true, false and false is true, in all cases it is false. So T biconditional to F is F. That's it. Okay. Now the last one in this is the fourth one, x square greater than 5, conjunction x minus 2 is greater than 5. This is the given concept, right? X square greater than 5. This implies 5 square, 25 is greater than 5, conjunction 5 minus 2. 5 minus 2 is 3 is greater than 5. So what do you say? 5, definitely 25 is greater than 5. It is true. This is true. Conjunction 3 is greater than 5. 3 is less than 5. This is false, right? This implies in case of conjunction, true and true is true. In all cases it is false. True and false is equal to false. This is how we are going to write the truth values for the given statement depending upon the value of x. Hope you followed this very important type of problems. Now let's move on to the next problem. 13D. Verify whether the given proposition P and, that is conjunction, P conjunction negation Q conjunction negation or conditional to P conjunction negation Q is a tautology or a contradiction. Now write down the truth values for this. First write down P, then Q, then R. We have P, Q, R, P, Q, R. Then write down negation Q, negation R, negation Q, negation R. Then P, yes, Q, negation Q, disjunction, negation R, negation Q, disjunction, negation R. Then P conjunction, negation Q, disjunction, negation R. Then, and the last one is P conditional to negation Q. Now, let us write down the conditional for this. Call it as X, this is X and Y. Write down the conditional, X conditional to Y. That's it. This is how we are going to write the truth table. Okay. Now, so 8 set 1, 2, 3, 4, 5, 6, 7 and 8. Now, just listen. P, Q, R, negation Q, negation R, then negation Q, disjunction, negation Q. Again, P conjunction, negation Q, disjunction, negation R. This is X. And P conditional to negation Q. And the conditional for X and Y. We have to verify whether this compound proposition is tautology, contradiction, or neither tautology nor contradiction. Just construct the truth table, that's it. Now, as you know, the truth values for this P is true, 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 false, 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 false. Again for Q it is T, T, F, F, T, T, F, F. Now, whereas for Q, for R it is true, false, true, false, true, false, true, false. Now, negation of Q. Negation of Q, for T it is F, for T it is F, for F it is T, F it is T, F, again F, T and T. This is the negation of Q. Negation of R. Negation of R is false, true, false, true, false, true, false, true. This is the negation. Now, write down the disjunction for negation Q and negation R. So, the disjunction for these two. Disjunction means false and false is false, in all cases it is true. So, false and false is false, false and true is true, true and false is true, true and true is true, false and false is false, false and true is true, true and false is true, true and true is true. So, in case of disjunction, false and false is false, in all cases it is true. Now, write down the conjunction. Now, conjunction for these two, P and this. Conjunction for P conjunction, negation Q, disjunction, negation R. The conjunction means true and true is true, in all cases it is false. True and false is false. Again true and true is true. Again true and true is true. Again true and true is true. Again false and false is false. Again false and true is also false. False and true is equal to false. False and true is also equal to false. So, in case of conjunction, true and true is true, in all cases it is false. So, conjunction of true and false is false, true and true is true, true and true is true, true and true is true. Again false and false is false, false and true is false, false and false is also false, and again false and true is also equal to false. Now, just write down the conditional for P and negation Q. P and negation Q for these two. Conditional true and false is false, in all cases it is true, right? So, conditional for P and negation of Q, So, this one, true and false is false, again true and false is false, again true and true is true, again true and true. True and true is true. Again, false and false is also true. False and false is also true. Again, false and true is also true. And again, false and true is also true. This is the conditional for P and negation Q. See, P and negation Q. So, true and false is false. True and false is false. True and true is true. True and true is true. False and false is also true. False and false is true. False and true is true. False and true is also true. Now, finally, write down the conditional statement for X and Y. Now, write down the conditional for these two. Conditional, again conditional, true and false is false. In all cases, it is true. False and false is true. True and false is false. True and true is true. True and true is also true. False and true is also true. False and true is also true. False and true is true. False and true is true. So, here true and F is F. In all cases, it is true. So, therefore, this is neither a tautology nor a contradiction. Suppose if you get all the truth values as T, 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 if it is T, then it is called a tautology. If all the truth values as F, 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 then it is called a contradiction. Here, this is neither tautology nor a contradiction. So, therefore, it is neither tautology nor contradiction. So, this is how we are going to construct the truth table for 8 marks. Very simple and very important problem. So, in this question number 13, usually you will get 8 plus 8, 16 marks. 16 marks from, that is logic chapter. Logic chapter is very important. So, if you practice the truth table, definitely you will get 16 marks from this chapter. The very easiest question. That's all regarding today's session. Let us meet with different questions in the next session. Thank you very much.